So, you finally finished building your beautiful Next.js application. It has countless features baked in. Who knows, maybe this application will finally make you a multi-millionaire. But have you thought about the most important thing? No, I'm not talking about dark mode, but rather about security. One bad dependency could drain your users' bank accounts. One misplaced API key could leak your secrets to the client side. And one careless HTML property could let attackers run scripts inside of your application. But don't worry, in this video I will show you 6 security mistakes that a lot of people make whenever using Next.js, and more importantly, how to avoid them before they cost you everything.
Nice.
So, without any further ado, let's go! Alright, so let's start with security pitfall number 1. And this deals with NPM packages. Since when is it a mistake to use NPM packages? Good question. So let's imagine the following. You are building a groundbreaking website and now you need a specific feature where you determine if a number is even or odd. Now let's imagine that you skipped mathematics in school and you don't know how to calculate that natively. So what would be the easiest solution? Well, how about you use an NPM package, like for example isOdd and isEven. In this case, for example, isOdd has almost 500k weekly downloads, and the whole idea is super simple. You just get a function isOdd, and as an argument you pass the number. If you pass an odd number, it will return true. If you pass an even number, it will return false. Yeah, I know, groundbreaking. Let's test it out. If I pass 2, it will return false for isOdd because the number is even, and it will return true for isEven because the number is even. Yoo-hoo! So now you might ask me, hey Jan, so why is it a mistake to use these NPM packages? They work, they have a lot of weekly downloads, so I don't see the problem. A few people might say bundle size, but who cares about bundle size right now? We specifically only care about security. Well, the problem is actually not the package itself. It's the ecosystem, the NPM ecosystem in general. So I don't know how up to date you are, but recently we had a huge NPM supply chain attack which put billions of weekly downloads at risk. Oh no! So what happened? Well, on September 8th, 2025, the JavaScript ecosystem faced a major supply chain attack targeting 18 widely used NPM packages. These packages alone see over 2.6 billion downloads each week, making this one of the most significant NPM attacks in recent memory. So what exactly happened? Or what packages did even get attacked? Well, let's look at the biggest ones. For example, ANSI styles with 400 million weekly downloads, not 1,000 but million. Debug.js with almost 400 million downloads per week, and Chalk with 320 million weekly downloads. These are huge packages, and again, in total 18 packages got attacked, but these are the biggest ones. So what happened? Well, actually the developer got phished. He got an email saying, hey, please update your 2-factor authentication credentials. You know, security, because you are a developer, just do it. And what did the developer do? Well, he clicked on the link and he gave the hacker access to the packages. What did the hacker do? Good question. He created a patch version, so for example 6.2.4, and in this patch version he added malicious code, and this malicious code tried to drain crypto wallets from users. So I think you all know what MetaMask is. Pretty much this hacker added code to then attack the MetaMask wallet to then get all of the money from users' wallets. So if you had MetaMask installed and used ANSI styles, well, I guess I'm sorry for you. But okay, it got patched quite quickly, so probably nothing happened to you. Nevertheless, this was a huge attack. And that's the problem with using packages. You don't own them. Somebody else maintains them, and you trust the maintainer to create good code and to not get hacked. But sometimes it happens. We are all humans. So for simple packages like is_odd and is_even, the solution is quite simple. Don't use them. Use native code, because at the end of the day, it's quite simple. Use the modulo operator. This is this percentage symbol, and it literally just computes the remainder when n is divided by 2. And with that, you will then know if the number is even or not even. But now you might say, yes, Jan, this is true, and you probably shouldn't use these small packages, which can be pretty much simplified by yourself using your own code. But what about ANSI styles, for example? This is not a simple package. What I mean by that is the code is not very simple. Creating the code yourself wouldn't be easy, so it kinda makes sense to use a separate package. Yes, that's right. So what should you do now? How can you protect yourself against malicious users, hackers, which hack these accounts or these packages? Well, I will give you 2 best practices. First of all, don't use the latest version. I know we all love the latest versions of XYZ. We love to live on the bleeding edge. But trust me, sometimes it's better to trail a bit. So if the latest version is 2.11, then how about you try out 2.09 or something like that? You don't always have to use the latest version. Sometimes it's safer to trail a bit. Secondly, review the package. Is the maintainer actually a good maintainer? Look at the code. Is the code good? And from then on, you will already know if you can use the package or not. Don't install random packages which you find on NPM, because not all of them are safe and maintained. And yes, maintained is an important thing. Please make sure that the package is maintained. And also one thing which a lot of people don't know is that actually most packages build on top of other packages. As an example, this is the AWS SDK signature package, and this package builds on top of other packages, on top of other dependencies. So sometimes you install one dependency, but this dependency has 100 other dependencies down below. So please make sure that you actually review what you install. Don't install random things. Make sure that the package is maintained and that it's actively used. Okay, so now let's continue with security pitfall number 2. And this deals with data validation and data sanitation. Yes, I think you all remember 2020 when we had to sanitize our hands, and now we want to sanitize our data. So let's look at this example. Inside of here I have a content submission form where the user can input a name, an email, and some content. And this content input is pretty much a text area which allows for anything. The user could input random text or maybe some HTML elements, maybe some scripts, who knows, literally anything. So in this case, let's say for the name, this will be Jan Marshall, for the email, some gibberish, and then for the content, this will be hello world. These inputs are safe. So if I click on submit content, everything is fine. And now you might ask me, hey Jan, here you render unsafe rendering, raw HTML output, safe text output. What does this mean? Good question. Let's look at the code. This is just an export default function, and inside of here I render a component called simple form, and this is my form itself. So I set up a useState hook, and inside of here I initialize my properties, the name, email, and content, and then in the return statement I just set up the form itself. Here I have my input for the name, then for the email, and then the text area for the content with a value and on-change handler. Now this is all fine, just a simple form, nothing groundbreaking, nothing unsafe initially right here. And if I have submitted content content, then I render this component unsafe preview. Let's open the unsafe preview, and inside of here I literally get my content, specifically the data which gets inputted into this text area, and then I do two things. First of all, I just rendered normally in this div, and then I also use dangerously set inner HTML. So let's again go back. If I say hello world, then in both outputs it renders the same thing. So in the raw HTML output, this is this dangerously set inner HTML, it renders the same thing as in this div. And the main difference is that in this div, where we don't use dangerously set inner HTML, it escapes the content automatically. But this also means that I can't use any HTML elements. So here I have an example. Try entering this or that. So let's test out this h1. So inside of here, let me just paste it, h1 hello world, and then I also added a class name with text 3xl. This is safe content, this is fine. If I submit the content, then you will see at the bottom the safe text output literally just renders the HTML. But the raw HTML output, that's the dangerously set inner HTML, actually renders the real HTML. That's why the text is now bigger. I could also add a class name with a color, so text red 500, and then it would also be inserted inside of here. So dangerously set inner HTML takes the content and sets it into the DOM itself, and this div without dangerously set inner HTML escapes the content. Now in most cases you want to use the second option, but in some cases you want to render the HTML which the user inputs, because maybe you have some sort of developer block where users input HTML. Now again, in this case this is all fine, this is safe, but now let's imagine that we have some sort of malicious user who thinks that it's a good idea to hack our website. Sadly, there are a lot of such people out there. In this case, the user now adds an image with a fake source and then an on-error handler. And if the source has an error, then we will just have an alert which will say XSS. If I now submit the content, oh no, what is this? Is this an alert? Did I just get hacked? Well, I did not get hacked, this is just an alert, but in theory the user could now add a script which would create some sort of XSS attack and drain our users' bank accounts, which we don't want. And what even is XSS? Good question, because this is a term thrown around quite often, but most people don't even really know what it means. It's actually quite simple. So here we have our hacker, and this hacker discovers a website, in this case our website, having a vulnerability that enables script injection. And this could literally be any script. As an example, this hacker could add a malicious script that steals each visitor's session cookies. And now whenever a normal visitor, like me or my friend John, visits your website, the malicious script will be activated, and with that all of my cookies will be stolen, if this makes sense. So this hacker will get all of my session cookies, which of course shouldn't happen. So in this case, this is not a real XSS attack, but of course I could add a script inside of here and then create a real malicious attack, which I don't want to allow as the creator of this website. So now you might ask me, hey Jan, what's the solution? I still want to allow my users to implement or add HTML, but of course I don't want to allow users to add scripts or to create XSS attacks or anything like that. It should be standard HTML, which is safe. How can we validate the user input? Good question. So in this case, we still want to use dangerously set inner HTML, but we can pretty much clean up, sanitize the content using one package, which is called DOM Purify. DOM Purify is a DOM-only, super fast, super tolerant XSS sanitizer for HTML and a few other things. It was started in 2014 and now it has already iterated quite often, and it's super safe to use. No, it did not get hacked recently or anything like that. And what does it do? Well, DOM Purify sanitizes HTML HTML and prevents XSS attacks. So you can feed DOM Purify with a string full of dirty HTML and it will return a string with clean HTML. And you can configure it so you can say, hey, only allow these elements, only allow these scripts, only allow images from this source, and so on and so on. So I created another component which is called save preview. So inside of here, we again get our content. This means the input which has been generated inside of here. And then we set up DOM Purify. So we use the sanitize method as an argument. We pass the dirty content, the dirty HTML, and then we configure DOM Purify itself. This means we only allow certain elements like H1, H2, H3, EM, strong, and stuff like that. Then here we specify which attributes we allow and a few other things. And then at the bottom, we literally just return everything. And then we again use dangerously set inner HTML, but now with the sanitized content. This means instead of using the unsafe preview, I will now use the save preview. And if I go back and again paste the image with this alert and click on submit content, nothing happens. We now sanitize the HTML output and we don't allow images, which means nothing gets outputted. But if I still just pass a standard H1, so let's take this one for example, and if I paste it inside of here, it will still work. So here it now says hello world. So DOM Purify is a very essential package which you should use whenever you don't control the HTML. In this case, many users can input HTML inside of here. I don't control the input, which means it's essential to use the package. And then there's one more thing which I would recommend, and that's of course data validation. So here we have two inputs for the name and email, and we expect a certain schema. So the name should have, for example, at least 2 characters and a maximum of 50, and the email, well, it should look like a real email with an @ symbol and then a .com or .us or whatever. So we probably have some sort of schema in mind. Now you might say, hey Jan, validation is, you know what, relatively simple. We can just use these properties like type email or for example required. This is already quite good validation, right? Yes, this validates the data, but on the client side and only on the client side. But as you all know, whenever you use forms, you in most cases have the client side and server side. This means you want to validate the data on both sides. Now you can't really use this code on the back end. You could create your own function, but this is quite annoying and it takes a lot of code. So my recommendation to you would be to create a separate schema using sort. So in this case, I, for example, created an example schema with sort with all of my properties. For example, my name, it should be a string with a minimum character length of 2. I added my own custom error message. Then for the email, it should have a valid email format, again with my own error message. And the same thing is also true for the content. Now in this case, for the content, I also implemented DOM Purify. So I added the transform method. And now whenever the user pretty much inputs data, I will first of all check it on the client side, then on the server side, and then whenever I render it using my save preview, I will again sanitize it. So with that, I will just make sure that everything is fine. And then in my simple UI, I can literally just go in the handle submit, and then inside of here, I can create a constant result, which will be equal to validate form data. And you know what? Let's console log the result. If I now add a name, an email, and then also some content and click on submit and open my console, you will see inside of here that this was successful. Success true. But if I now forget my name and only add an email, then it will fail because in my console it will now say something like, let's see, object success false. And that's because this was required and I did not input anything. So yeah, these are my 2 recommendations. Sanitize your content if you don't control it. In this case, I don't control it. And secondly, validate your inputs, both on the client side and server side. For example, a lot of people use server actions. Server actions are public endpoints. This means you want to validate the data on the server side. Some people will try to submit your form without using your UI. And if you only validate your data on the client side, then your server side will always be an entry point, you could say, for attackers. So this is very important to keep in mind, and please don't forget that. Let's now continue with security pitfall number 3. So this deals with environment variables. Environment variables are something that most people pretty much jump over because they aren't complicated, right? It's quite simple. In our Explorer, in most cases, we have some sort of .env file where we store all of our environment variables. And inside of here, I store a few environment variables. A server secret, which in theory is only available on the server side, an API key and store ID, which are also only available on the server side in theory, and a next public token. This is prefixed with next_public, which means it's available both on the server side and client side. So this is quite, you could say, standard. Most of us know how this works, nothing groundbreaking. But let's go to the example 3 page. So here I first of all have my server view. This is a server component, no use client directive or anything like that. And inside of here I get both of my values, the server secret and the next public token. As mentioned, the next_public token is available both on the server side and client side. And the server secret in theory is only available on the server side and not on the client side. But now I have this client view. This is a client component, so I marked it with the use client directive. And inside of here, I first of all get my next_public token. As you see, it displays the value because it's available on the client side. But what about the server secret? I also see the value, hello server. But what is if this would be super secret, something like that, our database URL or the password to our bank account? Well, we literally just leaked it to the client side. But now you might ask me, hey Jan, how were you able to leak your server secret? There is a reason why we have next_public and normal environment variables. These should be only on the server side. These should be both on the server side and client side. Well, let's look at the code. So this is my example 3 page.tsx. As you see, this is a server component. No use client directive. Inside of here, I get my 2 environment variables, server secret and public token. Then I render them at the bottom. So server secret and public token. That's why we see them right here. We are on the server side. So this is nothing groundbreaking. This is fine. Then I have a client component, leaky client. Let's open the leaky client component. What do I do inside of there? Well, it's quite simple. I again define my public token and server secret, and I get them from my env file. And then I render them at the bottom. First of all, the public token and then the server secret from my environment variable. And as you see here, we actually render the public token, but we don't render the server secret. It's undefined. But you know what? My stupid developer friend John actually made a stupid mistake and passed the server secret as a prop to the leaky client component, which is marked with the use client directive. So even though I defined the environment variable on the server side, I still leak it to the client side, because here I just rendered server secret, which is passed from the server side, and that's why I see it right here. And this is a huge mistake, and you might say, hey Jan, this is not a real issue. Who passes his secrets to the client side, to a client component? Nobody would do that. No, this is not true. I reviewed a lot of code bases from junior, but also mid-level developers. And you know what? I saw this mistake quite often, to be quite honest with you. And that's because it's quite easy to make the mistake. There's no error or anything like that. Everything works as expected. So how can we protect ourselves from such a huge mistake? Good question. Thankfully, there is an easy solution. So React has a feature called Taint, and Next.js also offers it. Currently, it's still experimental, but I tested it out and it works great. So what exactly does Taint do? So the Taint option enables support for the experimental React API for tainting objects and values. This feature helps prevent sensitive data from being accidentally passed to the client side. So when enabled, you can use experimental taint object reference to taint an object or taint unique value to taint a unique value. So what you want to do is open your next.config file. Inside of here, you can get the experimental flag and you want to set taint to true. Once that's done, you want to go back to your page.tsx, which is a server component, which means it's on the server side. And then inside of here, you can just go underneath this public token. You can add this code. So first of all, you check that the server secret is not undefined, so that it's actually defined. Then you import the function from React taint unique value, and inside of here you have to pass 3 arguments. So the first argument is the error message itself, which will be displayed if the value is leaked to a client component or in general to the client side. The second argument, in this case process, keeps the rule active for the whole server process. And the third argument, the server secret itself, is the exact sensitive value which we want to block from reaching the client side. So if I go back and try to reach the example 3 route, I instantly get an error. Do not pass any API keys to the client side or to the client in general. And this error message displayed. If I update it, of course I will get a different error message. I know a few people might think, hey, this will never happen, but trust me, it happens way more often than you might think. A lot of people do it, even people who know how to write good code. It just happens sometimes. So this Taint API is definitely a game changer, and I recommend you to test it out and give it a try. Let's now continue with the 4th security pitfall, and this revolves around data fetching. So inside of this page.tsx, I literally just fetch data from the GitHub API, and to be specific, I fetch data from the Next.js repo. This means stars, forks, open issues, stuff like that. Nothing groundbreaking. This is just a simple fetch. But here's the thing, this page should be a private page. Only authenticated users should be able to see this very private and sensitive data. And the thing is, a lot of people might think, hey Jan, it's quite simple. Let's get the user session in the page.tsx, and if the user does not have any valid session, then let's redirect the user. Well, this is actually a security mistake that a lot of people make, and it's very, very bad. And therefore, we have to somehow implement, first of all, authentication. So in this video, we will use Kind. Kind is my favorite auth solution, and thankfully, they even sponsored this video. What exactly is Kind? Well, Kind is the modern auth and billing solution for engineers. They offer everything from basic authentication to advanced authorization, and they even released billing recently, which allows you to monetize your ideas with game-changing billing tools. And soon I will release a huge 24-hour video covering a lot of cool things, including billing, so stay tuned. And if you want to try out Kind, then use the link in my YouTube description down below underneath the like button to get $50 in free credits. And now, without any further ado, let's implement authentication in 1 minute or so. And the first step is to sign in. Once signed in, you want to create a business with a business name, kind domain, number of employees, and region. My business has now been created successfully, and I can now open it. Here they provide us with a quick onboarding guide, so I want to use Kind with my existing code base. Then I use Next.js as my framework, and I want to allow users to sign in with email, Google, and let's say Facebook, because why not? And now we are almost finished and we want to now connect our Next.js codebase to Kind. Here they already provide us with a nice quick start guide to implement Kind in our codebase. So I will quickly follow it. You will also do it. And once finished, I will come back. Alright, I now implemented Kind and I also updated this specific environment variable. This is the post login redirect URL, and once a user successfully logs in, I will redirect the user to the example for route. And if we go back to our application, everything still works. Nevertheless, these two off buttons don't work. This means we want to use two components which Kind offers to start the off flow, and this is the login link and register link components. So I can copy the import statement. I want to open the navbar component and I can paste the import statement inside of here. As the next step, I want to get the user session because currently it's hard coded. So I will delete the constant user and instead I can create a new constant. I want to destructure it and this will be equal to get kind server session. Get kind server session is a hook which exposes functions that only run on the server side. In this case, I want to get the getUser function, which is a promise. That means I have to await it. So I now get my user session, which means I can use it in my ternary. If we have a valid user session, instead of rendering this button, I want to get the logout link component. And if we don't have a valid user session, I want to render the login link and the register link components. These components are headless, which means you have to style them. And if I go back and click on sign up, I will get redirected to the hosted authentication page. So users can sign in, or in other words register, with Google, Facebook, or for example with their email. In this case, I will continue with Facebook. No, I'm joking. I don't even have a Facebook account. So I will continue with Google. As you see, I got redirected back to my page and my navbar updated and it now says sign out, and that's because I now have a valid user session. As you know, I want to protect this route. Only authenticated users should be able to see this page. So let's again go back and let's open the page.tsx. So let's review it. Inside of here, I first of all render my navbar, then my main content, and in the main content, I render the data from my API call. Because if you scroll to the top, you will find this async function, and inside of here, I fetch data from the GitHub API, and to be specific, I get data from the Next.js repo. I fetch the data, and then I call the function in my export default function. This is possible because this is a server component, and it works nicely. But as mentioned, I want to protect this page. So how can we do that? Well, it's quite simple, right? Above this constant repo, we can use the getKindServerSession hook. We want to get the getUser function. This is a promise. Let's await it. And then we can create an if statement. If there is no user, this means if we don't have any valid user session, then let's redirect the user to /API/auth/login. If I save this and again go back and do a hard refresh, everything still works. But if I now copy the URL and open it in a new incognito tab, then I will get redirected to the hosted authentication page because I don't have a valid user session inside of here. So now you might say, hey Jan, where is the mistake? Everything works as expected. Yes, that's correct. But what's the core idea of React? Well, it's reusability. So let's imagine the following. This card, you know what, it's quite powerful. I want to render it in multiple places. In this example for route, in my about route, in my welcome route, who knows, who cares. So I want to reuse it in multiple places. So what would I do as a React developer? Well, I would break the code which is needed for this card into a separate component. So that's what I did. Here I have a reuse component. I have my async function to fetch my repo data, and then at the bottom I literally just render this card and I await the data inside of here because this is also a server component. This means I can now delete the async function from here. I don't need it anymore, and I don't have to fetch my next repo data inside of here anymore, and instead of of rendering this div, I can just render my repo card component imported from the same directory. If I go back and do a hard refresh, everything works. If I copy the URL and open it in a new incognito tab, everything still works. I got redirected to the hosted authentication page because I don't have a valid user session. So again, here comes the question, where is the problem? Well, we just created the problem. We made a huge mistake. This is now reusable. This means I can now go into my Explorer and let's create an example route. And inside of here, I can just render my repo card component. So this means let's go back, let's open the example route. And as you see here, I get all of my data. But now here comes the problem. How about I copy the URL and open it in a new incognito tab? My sensitive data got leaked. No! What happened? Well, here's the thing. Where do we check the user session? We check the user session in the page.tsx itself, inside of here. And when this reuse component is used in the page.tsx, this code runs, which means we validate the user session. But in the example page, we don't fetch the user session anymore, which means we just fetch the data without any authorization, which is not good. How would you fix this problem? Well, one solution could be to copy this code and paste it into the reuse component. This works, but you know what? This is not recommended by the Next.js team. Instead, they want you to create a data access layer, or in short, DAL. But what even is a data access layer? So as they say, we recommend creating a data access layer to centralize your data requests and authorization logic. A data access layer should include a function that verifies the user's session as they interact with your application. This sounds a bit more confusing than it has to be. In short, they want you to create a separate location and centralize all of your data logic inside of there, including the authorization logic. So in this case, it would make a lot of sense to go into the app folder and to create a data folder. Then in the data folder, I would create another folder, in this case GitHub, and then you want to create a file, and since in this case I want to get repo specific data, the name will be get repo data. And then inside of here, you want to pretty much put all of your data fetching logic. So if I go back to the reuse component, I can just copy the async function with the interface and I will paste it inside of here. Then of course you want to export it, and that's already it. We now have a data access layer, but currently we don't make sure that the user is authorized. This means in our data access layer in the data folder, we can create another folder which will be user, and inside of here I will create another file require user.ts, and inside of here I want to now check that the user has a valid user session. So I created another function, require user. I get my get user function using the get kind server session hook. I fetch the user session. If there is no user, I redirect the user, and if we have a valid user session, then I just return it. We can use the function require user in the get repo data file, and I can just call the function above this data fetching logic itself. This means await require user, since I don't need the user object itself. And that's already it. This is now finished. This means if I go back to reuse, I can just delete this whole code, and instead I can call the function fetch next repo, which is imported from my data access layer. So inside of here, I now don't write any query logic. I don't interact with the user session or anything like that. I literally just call one function and then I manage everything in my data access layer. This means the user authorization logic, but also the general data fetching. So if I go back and do a hard refresh, everything works. But if I copy this and open it in a new incognito tab, I will get redirected. Yoo-hoo! But you know what? We still have one problem. So this function get repo data should only run on the server side and it should only be called from the server side. But right now, literally anybody can call this function. This means both from the server side and from the client side. If I go back to the example route and if I mark this with the use client directive, I won't get any error. As you see, everything still works. And if I go back and do a hard refresh, I still get my data. Wait, what? I got my data on the client side? This function should only run on the server side because I have authorization logic, maybe private data. This should never happen. The functions stored in my data access layer should only be invoked from the server side. So how can we make sure that only the server side interacts with these functions? Thankfully, it's quite simple. On the top in the get repo data file, you can import server only. So server dash only. And if I go back and do a hard refresh, I instantly get an error and it says you are importing a component that needs server only. This works in a server component, but one of its parents is marked with use client. So it's a client component. So this server only import is a nice helper which makes sure that this code only runs on the server side. And the nice thing is this import server only or server only in general is automatically installed whenever you create a new project. So I would definitely urge you to use it. Whenever you want code to be only available on the server side, then import server only, and this is like an automatic, you could say try catch. If it sees that you are on the client side, then it will throw an error without you needing to do anything or any configuration. And this means if I go back to my example 4 route, everything still works, and that's because this is a server component. Alright, so let's continue with security pitfall number 5. My lucky number. So here's the thing, you might say, hey Jan, the idea of authorizing the user in the data layer itself is quite smart, but this creates one problem. Whenever you want to get your user session, in most cases you call headers or cookies or something like that. This means the whole page becomes dynamically rendered. But what is if you want to cache your data? So let's imagine the following. This here is super private data. Only authenticated users should be able to see it. No public users, please. Let's look at the code. So this is my page.tsx. This is just a standard export default function. I return my markup and then I map over my users. I fetch my users at the top and the function is defined in my data access layer as you see here. So I fetch data from this API and the important thing is that I cache my data. I added this revalidate tag. This means the data will be revalidated every 600 seconds. But if I now make sure that the user is authenticated by calling the require user function, I will opt this function and with that my whole page into dynamic rendering. But that's not something that I want to do. I want to leave this page static. It should be statically rendered. How can we make sure that the user or that this page is still private without opting it into dynamic rendering? Well, you might say, hey Jan, it's quite simple. How about we implement middleware? Middleware is like a layer in front of your server, which is very lightweight and it preserves static rendering. So pretty much when a user makes a request to your server, middleware will intercept the request and it will check if the user is authenticated. If not, it will redirect the user to the hosted authentication page, and if the user has a valid user session, then it will just forward the request to the server. And setting up middleware is very simple with Kind. Here they have a section set up middleware, and then they have a little subsection called opting routes out of middleware protection. I can just copy the code, go back, and then in my Explorer in the root directory, I can create a middleware user.ts file and paste the code inside of here. So now this middleware, as mentioned, will run on every request. It will make sure that the user is authenticated, and if not, it will redirect the user. Here we have a public paths property, which is an array. Inside of here I can pass all of the routes which should be public. In this case, for example, the index page. If I go back and do a hard refresh, everything still works. I can delete the require user call from my get users function, because in theory we have middleware, and if I copy the URL and open it in a new incognito tab, I will get redirected to the hosted authentication page. Nice! This is exactly what we wanted. We make sure that the user is authenticated, our page can still be statically pre-rendered, everything works. Sure, but this is a huge mistake, because you now rely on one single layer to pretty much intercept all unauthenticated requests. But what is if there's some sort of vulnerability? Then users which are not authenticated will see this data. And that's exactly what happened a few months ago. Recently, a critical vulnerability, which has now been patched, was disclosed in the popular Next.js framework, allowing attackers to circumvent middleware execution, including security checks, by leveraging an internal header. So what exactly happened? Well, the attack exploits the X middleware sub-request header, an internal implementation detail that was never meant to be exposed to users. Attackers could pretty much use this X sub-request header and with that circumvent pretty much this whole authorization layer. And this is why using middleware solely for authorization logic is a huge mistake. What you want to do is multi-layered authorization. You want to use middleware, but you want to still call the require user function in your data access layer. Sure, this won't be cached, but it's more important to make sure that your data stays private than to make it faster. So my recommendation to you is to run middleware in parallel with your data access layer, in which you make sure that the user is authenticated. If the middleware fails, then you have your data access layer. If your data access layer fails, you have your middleware. This is multi-layered authorization, which just pretty much gives the attacker a smaller surface to attack, because you have multiple, you could say, security checks. And finally, let's finish off with security pitfall number 6. And this deals with security headers. So what exactly are security headers and why should you care? That's a good question. So, HTTP security headers are important in protecting your website and its users. The users are the important thing here. They help prevent various types of cyber attacks such as cross-site scripting, XSS, clickjacking, and other code injection attacks. By setting these headers on your website, the headers instruct the browser on how to handle certain aspects of security, reducing the risk of data breaches and enhancing trust. So here's the thing, when you have a native Next.js application, it does not really ship any meaningful security headers or HTTP headers which help with security. Therefore, we have to do it by ourselves. And the thing is, there are a lot of security headers like HSTS or XSS protection, X-frame options, X-content type options. There are a lot of things, and these are just general security pretty much configurations, if this makes sense. So for example, the XSS protection response header is a feature that stops pages from loading when they detect reflected cross-site scripting attacks. So these security headers are literally just a super easy way to make your website way more resilient against malicious users. And now you might ask me, hey Jan, how can we implement security headers? Because at the end of the day, you still have to configure them. Does it not take a lot of time? Don't we have to open our layout and do all of this annoying stuff? No, thankfully not. There is a very nice helper function created by ArcJet which sets security headers for you automatically. Nevertheless, you can still configure them if you want to, but it's a very good starting point. So ArcJet Nosecone, this is the library, is an open source library that helps set security headers such as content security policy, CSP, HSTS and X content type options in JS applications. So here they showcase all of the supported headers. As you see, these are like the main ones, everything that you pretty much need. And setting it up is super simple. First of all, you want to install the package. And by the way, this is open source, not a paid service. This is just a package which does everything for you. So we can just install it quickly. Then the next step is to configure our application, and Nosecone applies headers to all of your routes via middleware in your Next.js application. So as you see, middleware is a great feature because we need it for authorization, but also for our security headers. So let's open our middleware file. I will quickly comment out everything and paste what I just copied. And you know what? In theory, this is already finished. There's only one more thing that we have to do, and that's that we have to update our layout. So we want to opt out of static generation to apply these headers. This means we can copy this await connection, and I will also copy the comment. Then I want to open my root layout, and above the return statement, I will call await connection. Connection is just a function provided by Next.js itself, and this will opt this route, or in other words, all routes, out of static generation, so that for every page we can apply security headers. And you know what? Let's test it out. I restarted my dev server. If I do a hard refresh, in theory, everything should still work, and it works. I will copy the URL, just localhost 3000, and in my terminal I can say curl-i localhost 3000. And if I click on enter, I get a nice response with a lot of security headers, like for example, referrer policy, no referrer, X content type options, no sniff, X DNS prefetch control, off. So these are security headers which are already configured to a good default. Nevertheless, there's one problem. Let's imagine the following. You have some sort of analytics software running in the background, let's say Plausible, then this won't work, because Plausible has scripts running to make the connection work and you share the data. And if you use Nosecone, or in other words, if you implement security headers, it will block this external script from Plausible. This means we want to also configure Nosecone, and configuring Nosecone is super simple. If you scroll to the bottom, you will find this section, example configurations. And this is an example configuration if you use Plausible plus YouTube embeds. So when you embed YouTube videos. This configuration applies the default Nosecone headers, but allows scripts from and connections to Plausible Analytics and YouTube embeddings from the YouTube no cookie domain. It also sets the upgrade insecure requests directive to true in production to ensure that all requests are served with HTTPS. So I can just copy this code, go back, paste it inside of here, and now we will allow Plausible and YouTube embeddings to work even though they have scripts running. So you can configure your security headers, because not every external script is a bad one. There are trusted ones. You have to just define them inside of here, the URL for example, and then it will work nicely. We can again test it out in our terminal. If I click on enter, as you see here, we still get all of our security headers applied, even though we configured them inside of here. And let me show you how it looks like if there are no security headers. And if I now go back and again curl my website, then you will see here that we don't have any security headers. We just get this link, cache control, content type. This is all fine. but these aren't security headers. This is insecure. So whenever you create a production build, trust me, you want to implement security headers, and as you see, it's super simple to implement with this Nosecone package. And the nice thing is you can chain middleware. Here they have an example on how to chain middleware. This will allow you to run, for example, the kind middleware, the authorization middleware, in parallel with the security headers, which is a game changer. So definitely try out the package, test it out. Let me know what you think, and let me know what you think about this video. Are there any other security tips that I did not mention? If so, please let me know. I would love to create another video in the future, maybe talking about other security risks which are not known very well. And now, I hope you enjoyed this video. Please don't forget to like and subscribe. It would mean a lot to me and my heart, so please do it. Thank you, Kind, for making this video possible. Check out Kind using the first link in the YouTube description. And now I hope I can see you in the next video. Enjoy your day and bye bye.